be talking about friction. We're going to use these two body, Einstein bust, body number 1, and the desk, body number 2, to create the definition of our friction. So the friction is a resistance body 1 experience not at rest, because when body 1 at rest, the friction is 0. Right now only 2 force acting on it, so there is no friction right now. Friction, there is a friction only if and only if body 1 try to move over body 2. Okay, this is very important. Right now I am applying 1 Newton, the force of friction is 1 Newton. I am applying 2 Newton, the force of friction is 2 Newton. Professor Einstein is 10 kilogram. What is his weight?
98 newtons.
What is his normal force?
Also 98 newtons.
How many force acting on Professor Einstein right now?
2.
If I apply 0 force, how many force acting on Professor Einstein right now?
Still 2.
Force of friction acting on Professor Einstein right now?
0.
0. Okay. If I apply 1 Newton, how many force acting on this body, body number 1?
4. The force, the normal force, the force of gravity, of course, they are always forces. And then we have your applied force of 1 Newton and the resistance or the friction, which is.
I'm glad that you use resistance. So friction is a resistance on body 1, if and only if the body 1 try to move using body number 2. That's the friction. There are 2 types of friction. What are they?
Well, there is static friction, which is friction on an object when it is not moving, and kinetic friction, which is friction on an object while the object is
Which one is bigger, static friction or kinetic friction?
Always static friction, no matter what.
There are 2 types of coefficient of friction. What are they?
Well, the coefficient of static friction and the coefficient of kinetic friction.
Which one is bigger?
The coefficient of static friction always, and that is why static friction is
alright,
always bigger.
okay, alright, very nice. What is the maximum frictional force possible on this body number 1, which is Einstein?
Well, you never told me the coefficient of static friction.
So
How
let's say coefficient of static friction is 0.4. Is that okay?
Alright.
What is the maximum force possible? Maximum static force possible on this body number 1?
Alright, and how much does Einstein over here weigh?
I said 10 kilogram.
Alright, so let's calculate. Beep, boop, beep, boop. Okay.
You need a calculator?
No, okay. So I have 9.8 times 10 times 0.4 is equal to beep, boop, 9.8 times 4 is... Oh, I got it. 39.2.
What is that? Kinetic friction.
What is the coefficient of kinetic
It's
friction?
always less than 0.4.
So what is it?
0.3, let's say.
Alright, so now let me think about it. So we have 9.8 times 10 times 0.3, beep, boop, 9.8 times 3, beep, boop, 29.4.
29.4.
Then here's the force body diagram. There will be no friction either.
By the way, quickly, we don't have time.
So it just...
No, you don't. Arrow is fine. You don't have to write those notation.
Okay.
Arrow
then
is fine.
We just have these.
Alright, what is the FG?
Okay, FG is 98 Newton.
What is the FN?
Also 98.
You don't have to write Newton. What is the FF?
Well, F of F is 0.
Okay, because applied force is 0. Static friction or kinetic friction?
Well, here it would be static friction,
Alright, check.
but the Oh, yeah.
Alright, kinetic friction. F net.
F net would just be 0.
The number of forces.
2.
Let's see, count 1, 2. Okay.
Wow.
Count backward. 1, 2. Okay. Acceleration.
The acceleration is 0.
Newton first law, second law. I'm going to apply 30 Newton. Go ahead. Update.
Okay, so when you apply 30 newtons, let's see.
How many vectors?
So we have 1, 2, and then we have your applied force, and then we also have number 4.
What is the weight?
The weight is still 98 newtons.
What is the normal force?
98.
What is the force of friction?
Force of friction is now 30.
What is it static or kinetic?
It is still static because it did not
Net
reach
force.
the threshold.
What is the net force?
The net force is still 0.
How many forces acting on it?
4,
What is the acceleration?
0.
Newton's first law or second law? Acceleration is 0 means Newton's first law. That's it. That's the end of this story. If you apply 39.2.
Okay, well, still, we have these 4 forces, and Fg is 98, and so is Fn, and then Ff here is just at the threshold, but it still balances out with Fa. FFS, it's still FFS and not FFK.
What is the F net?
Fnet is 0 because everything cancels out.
Right. Forces, how many?
There are 4.
What is the acceleration?
The acceleration is 0.
So what law is it? First law, second law?
Still the first law
Why
because,
first law?
as you can observe, Fnet and acceleration are both
That's
0.
it. F net is 0, acceleration is 0, first law.
So at 40, we have Fa.
What is the FG?
Fg is 98 newtons.
What is the Fn?
98 newtons.
What is the FF?
It is now 29.4 newtons.
What is the, is it static or kinetic?
It is kinetic.
F net.
Fnet is now, well, what is the applied force? 40. So 40 minus 29.4 is equal to 10.6.
What is the forces? How many forces?
Still 4.
And what is the acceleration?
The acceleration
Show me
now,
by Newton's second law. Right, F equal ma.
well, we know
F net
that
equal to ma.
Fnet is equal to ma, and we know what Fnet is. It's 10.6. We know what m is. It's 10. So now all we have to do is find a, and that's 10.6 divided by 10, which is 1.06 or 1.1.
Alright, so write 1.1. Alright, Newton's first law, second law.
It's the second law because,
Why?
as you can see, Fnet and a are non-zero.
Okay, so is it constant velocity rest or increasing velocity?
Since the acceleration is non-zero, it is increasing velocity.
Increasing velocity means acceleration is 0?
No, it means that the acceleration is positive.
Okay,